NASA's James Webb Space Telescope has captured unprecedented pictures.
NASA unveiled pictures from a new space telescope capturing the deepest images of the universe anyone has ever seen.
Suspended in the silent void of space, far beyond the reach of our planet's glowing blue shell, the James Webb Space Telescope peers into the deep. It doesn't just look, it listens, deciphers, reveals. With the cutting-edge instruments it carries aboard, this marvel of human engineering has become our window into the earliest epochs of the universe and the dark corners of space we never thought we'd reach. But nothing could have prepared scientists for what the telescope has just detected. A horrifying object that challenges not only our understanding of astrophysics, but the very boundaries of reality as we know it. Before we start, smash the like and subscribe buttons for more updates. The detection began like any other observation. Positioned to survey a distant region of the cosmos several billion light-years away, the telescope was gathering data on a cluster of ancient galaxies nestled in a region of low cosmic noise. These galaxies, relics of the early universe, are often targets of interest for their potential to reveal secrets about the birth of stars and the evolution of structure in the cosmos. But hidden between these stellar formations was something else, something that shouldn't have been there. It didn't emit light in the traditional sense. Instead, it appeared as an absence, a tear in the field of view, something that warped the data stream like a whirlpool in the fabric of space. The initial assumption was a technical glitch. Interference maybe, or a sensor anomaly, but the data was clear and repeated. This object wasn't a malfunction, it was real and it was interacting with its environment in a way that defied every known model. What made the discovery terrifying was its gravitational signature. It wasn't just dense, it was monstrously dense, more so than any known black hole, yet it showed no sign of forming from stellar collapse. The Webb telescope detected gravitational lensing around it, an intense warping of the light from background galaxies, twisted into spirals and halos far more distorted than what typical black holes generate. This meant the object was influencing light and spacetime on a scale far beyond expectation. Yet it wasn't entirely silent. Infrared instruments aboard the telescope caught strange rhythmic pulses emanating from the region. These pulses weren't random. They followed a sequence, almost like a cosmic beat, occurring in intervals that were too regular to be natural. The emissions weren't composed of particles or waves typically associated with energetic celestial phenomena like pulsars or quasars. Instead, they had properties that physicists are still struggling to classify, somewhere between high-frequency radiation and something entirely new. The object's structure, or lack thereof, was equally disturbing. It had no clear boundary, no event horizon, no surface. It seemed to be a concentration of energy and mass wrapped in an irregular oscillating field, flickering at the edges like a mirage. Observations suggest it may not even be entirely located in our dimension. Its gravitational pull is felt, but its mass is smeared across what some theoretical physicists now hypothesize could be a higher dimensional framework, something that interacts with our universe only partially. If that wasn't unsettling enough, its presence is altering nearby space in ways never observed before. Gas clouds within its vicinity are behaving strangely, coalescing and dispersing in chaotic patterns, forming spiral structures and filamentary webs as though something invisible were shaping them from within. Time dilation effects have been inferred from light traveling near it. Light that should have reached us in days took weeks to arrive, its path distorted by an influence that seems to ripple through space like a pebble tossed into a black lake. This kind of distortion implies that the object doesn't just warp space, it may consume or rewrite it. Models generated by data analysts suggest that the surrounding region is slowly being pulled into a space-time funnel that has no definable exit. The matter falling in doesn't emit the telltale X-ray flares associated with black holes. It simply vanishes. No bursts, no echoes, just erasure. It's as though the object doesn't consume matter so much as it deletes it from existence entirely. Equally disturbing are the simulations of what this object could represent. One model proposes it might be a relic of the early universe, a primordial sink formed moments after the Big Bang, made not of atoms or particles, but of raw distortion. Others suggest it may be a form of dark energy knot, an unstable construct of the same unknown force accelerating the universe's expansion. Even more radical is the idea that this object could be an artificial structure, built or left behind by a civilization capable of manipulating space-time itself. If that's true, then it raises questions no one is comfortable asking. Who or what could construct something like this? What would be the purpose of such a structure? Is it a weapon, a remnant, or perhaps even a form of cosmic engine? And more hauntingly, is it still active? The regular pulses detected by the Webb telescope continue. Their cadence has not changed. Some experts have speculated that these pulses could be a kind of code or beacon, although no existing algorithm has been able to parse a message. More unnerving still is the discovery that the object is moving. Very slowly, almost imperceptibly, it's drifting through the void, not in a way that can be attributed to gravitational drift or the pull of nearby masses. It seems to be moving with intention, aligning with a specific trajectory through the galaxy cluster. That trajectory has no clear destination, yet, but simulations predict that its path will intersect with a star system located hundreds of light years away in a few million years. For now, the object remains in deep space, inaccessible and untouchable. But its implications are reaching far and wide, not just in the corridors of observatories and space agencies, but in the foundations of physics itself. The existence of such a structure or entity could upend everything we understand about matter, energy, and the fabric of the cosmos. Standard models of physics, which already strain to account for dark matter and dark energy, cannot explain this. It is a new category of existence, one that operates beyond the observable laws of our universe. The psychological impact on the scientific community cannot be overstated. Some researchers have privately admitted unease at continuing to observe the object. Its mere presence seems to exert an intellectual gravity, a pull of questions with no satisfying answers, and a creeping realization that the universe may be far stranger, far more hostile than we ever dared imagine. There's something primordial and unknowable about it. It doesn't fit into our taxonomy of celestial phenomena. It's not a black hole, not a star, not a planet, not a nebula. It is other. There's also a growing fear that this might not be the only one. If this object has gone unnoticed until now, despite its immense gravitational influence, how many more could be lurking in the dark voids between galaxies? What if these are common in the structure of the cosmos, hidden in places we've simply never looked with the right tools? The Webb telescope, with its unparalleled sensitivity, may have simply peeled back the first layer of a terrifying cosmic reality that has always been there, waiting. The implications ripple outward. Not only must theoretical physics be re-evaluated, but our assumptions about the safety and isolation of our solar system are being quietly reconsidered. If such objects move, and if they move with intention, then passive observation may no longer be enough. Some voices are advocating for new missions, ones designed not just to observe, but to monitor the deeper gravitational maps of space, to anticipate anomalies before they reach closer proximity. The thought that something of this scale and nature could drift toward our region of space in the future is no longer relegated to science fiction. But even that is secondary to the deeper question: what is it for? Its properties don't suggest random natural formation. The energy pulses, the regular rhythm, the gravitational precision, it feels orchestrated. Some now think this object may be a kind of cosmic test, a mechanism or artifact left behind by a force beyond comprehension, one that measures, calculates, or perhaps judges. It may not be malevolent, but its indifference could be worse. Indifference implies no regard for what it consumes or what it affects. The James Webb Space Telescope was designed to uncover the secrets of the early universe, to look farther and deeper than any telescope before it. In doing so, it has also exposed us to the profound darkness and unpredictability of the cosmos. We are reminded once again that space is not empty. It is full of the unknown. The universe is not a quiet, sterile void. It is a place of strange events and stranger objects, where the rules we rely on do not always apply. This horrifying object, still unnamed, still not fully understood, is the embodiment of that realization. It exists not just as a curiosity, but as a challenge, a signal that we have much further to go in our understanding of the universe. It dares us to look closer, to ask harder questions, and to accept that some answers may never come. It is the shadow behind the stars, the silence between the pulses, the cosmic truth that for all our science and progress, we still walk in mystery. The silence in the control rooms belied the tension simmering beneath the surface. As data continued streaming in from the James Webb Space Telescope, teams around the world scrambled to process what they were seeing. Each department, astrophysics, quantum mechanics, cosmology, instrumentation, had their own piece of the puzzle, yet none could form a coherent picture on their own. Whatever this object was, it lay at the intersection of all disciplines and none. It resisted classification, sidestepped expectations, and worse still, it mocked the predictive capacity of even the most advanced simulations. The most unsettling new observations came not from the object itself, but from its effect on reality. A patch of space directly behind the object, from the telescope's point of view, had begun to darken unnaturally. Not due to light blockage or dust clouds, but because photons were no longer making it through. It wasn't an eclipse or an occlusion. It was as if light was being absorbed or redirected in a nonlinear path, bending not just around mass, but possibly slipping out of the observable universe entirely. That defied even the most generous extrapolations of general relativity. Einstein's equations worked up to a point, but this object operated beyond that boundary, in a domain where conventional gravity collapsed into something unrecognizable. More peculiar still, entangled particles used in observational studies, part of a quantum experiment piggybacking on the Webb's deeper scans, began to behave erratically when the object was in the observational field. Normally, synchronized reactions began to drift, with one particle seemingly responding to a change in its pair before that change occurred. It was a temporal discrepancy that no one had anticipated. Time, or at least causality, appeared distorted in the object's presence. This opened the floodgates to an entire new avenue of dread. What if this object wasn't just bending space and light, but time itself? If temporal fields could fluctuate in its vicinity, then its movement might not be linear. It could already be influencing regions of space that we perceive as distant in time, but are actually part of its trajectory. That was a scenario no current cosmological model could adequately accommodate. It also brought with it the disturbing possibility that the object's presence had been affecting cosmic history for longer than we had known. Like a ghost embedded in the timeline, unseen but ever present, shaping events from the background. Another startling observation came when gravitational wave detectors like LIGO and Virgo began to notice faint ripples aligning with the pulses detected by Webb. These weren't the signature waves from neutron-star collisions or black hole mergers. They were smaller, fainter, and too uniform, emerging not from explosive events, but seemingly from oscillations in space itself. The object wasn't just a mass anomaly, it was a gravitational oscillator, emitting perfectly timed waves at intervals too precise to be natural. The implications of that were staggering. Gravitational waves had long been thought to be byproducts of massive, high-energy interactions. The idea that something could produce them intentionally, regularly, and without accompanying cataclysm suggested intelligence. Not necessarily sentience, but certainly control. Control over fundamental forces on a scale that bordered on godlike. This wasn't just energy generation, it was energy sculpting, bending the very framework of existence with a kind of surgical precision that human technology couldn't hope to replicate. Further analysis revealed another confounding factor. The object appeared to be static in entropy. Despite absorbing matter and warping time-space, its entropy remained constant. It neither degraded nor evolved, suggesting a closed system operating outside the bounds of thermodynamic law. This raised questions about its origin. Was it truly ancient, as initial light delay measurements suggested, or was it something that had always been? An anchor point in the universe's structure, perhaps seeded during the formation of space-time itself? As theoretical physicists tried to model these behaviors, the conversation quietly shifted from what is it to why is it. No celestial object simply exists in contradiction to every known law without purpose or origin. Its coherence, its interactions, and its uncanny stability over observed timescales suggested intent, or at least design. For the first time, the term cosmic artifact gained serious traction in academic circles. If the object was artificial, it wasn't just a relic of an advanced civilization. It was a construct embedded with knowledge, perhaps instructions or processes far beyond our scope. Some hypothesized it might be a dimensional stabilizer, a relic left behind by universe-building intelligences, what theoretical astrophysicists refer to as Type V civilizations on the Kardashev scale, far beyond our current ability to even comprehend. If true, then the object might not be moving through our universe by accident. It might be maintaining boundaries between dimensions, fixing tiers in space-time, or perhaps acting as a regulator for the multiverse, if such a structure exists. Under this hypothesis, the object's movement and emissions weren't random. They were updates or corrections, like a program running in the background of cosmic software. Yet another chilling possibility emerged from string theorists and researchers in quantum gravity. The object may be a manifestation of what's been termed a brain scar, a remnant from when two higher dimensional membranes collided during the early moments of cosmic inflation. If our universe is a 3D surface floating in a higher dimensional space as string theory proposes, then collisions between such universes could leave behind punctures or anomalies. This horrifying entity might be one such remnant, a cosmic wound that never closed, bleeding gravitational and energetic irregularities into our cosmos. Under this interpretation, the pulses might not be signals but tremors, seismic reverberations from a rupture in a multi-dimensional field, like an earthquake echoing across layers of existence. The more we observe it, the more the analogy feels appropriate. This isn't an object, it's a fault line. And if that's true, it may not be alone. Others could exist in regions of space too distant or dark to detect, yet they might be contributing to unexplained anomalies across the universe. Gamma ray bursts, fast radio bursts, dark flow, and even the accelerating expansion of the cosmos. Observational physicists began to search surrounding regions for secondary phenomena. What they found only deepened the mystery. Faint concentric rings of microwave distortion appeared around the object's general area, like ripples on a pond. They were subtle, buried beneath the cosmic microwave background radiation, but they were there. These rings weren't evidence of motion, they were evidence of events, as if the object had previously activated or interacted with space and cycles. Some researchers suggested these might be footprints of an unknown cosmological mechanism, perhaps the awakening of an object in dormancy. Another theory emerged, terrifying in its implications. What if the object was not an anomaly but a probe? Not a telescope but a sensor? A kind of cosmic recorder built to monitor universes left behind by entities that seeded reality and then retreated, perhaps into dimensions beyond our reach. In that case, the pulses might be logs, transmissions or updates being sent somewhere, not necessarily within our space-time. And what if the arrival of intelligent life capable of observing the object triggered some form of observational recursion? A feedback loop where we're not only watching it, but being watched in return. That possibility wasn't lost on communication theorists. Hidden within the pulses were micro-fluctuations at frequencies that did not naturally occur in the cosmic spectrum. While they appeared random, some analysts noted patterns resembling binary encoding, 1S and 0S, spaced in sequences with increasing complexity. It wasn't language, not yet, but it could be the building blocks of one. It might be that the object's creators built it to wait for intelligence to develop, then begin transmitting the fundamentals of contact, beginning with mathematics, the universal language. The ethical and philosophical questions this raised shook the academic world. Are we ready for such contact if that is indeed what this is? Would engaging it risk triggering unknown consequences like poking an organism we don't understand? Or is passivity more dangerous? What if we are being tested for our ability to observe, analyze, and respond? It was a scenario that has long belonged to science fiction, but now it crept into the peer-reviewed journals and the hushed war rooms of major space agencies. Meanwhile, long-range telescopes trained toward the object began to notice subtle changes in the stars behind it. Stars that should have been visible were no longer there, not because they had moved, but because their light had stopped. Not faded, not dimmed, stopped. It was as though the object was altering or suppressing the timeline of photons en route to us, as if collapsing potentialities before they manifested. This was far beyond gravitational lensing. It hinted at manipulation of probability itself, a concept tethered to the frontier of quantum mechanics and reality construction. CERN, the particle accelerator laboratory in Switzerland, quietly launched an initiative to test whether the object's influence was measurable in high-energy particle collisions. To everyone's astonishment, it was. Certain particle events, normally predictable within nanoseconds, began to show variances in decay signatures during observation windows that overlapped with Webb's ongoing scans of the anomaly. These shifts were microscopic, but statistically significant. Somehow, an object billions of light-years away was causing particles in Earth-based accelerators to behave differently. That discovery led to a breakthrough hypothesis. The object may not be entirely there. It may exist as a quantum-entangled structure, one node of which occupies deep space, while others are folded into other locations, perhaps even within the very fabric of matter itself. In this sense, the object is not moving through space, but unfolding, revealing aspects of itself in different regions of the universe simultaneously. This would make it less an object and more a topological phenomenon, an echo of higher dimensional architecture intersecting with our 3D universe. That concept turns the entire idea of space exploration on its head. If such entities exist, not as constructs within space, but as folds of space itself, then the universe may be teeming with intelligences and artifacts we cannot perceive because we are blind to dimensions they operate in. This object could be the first glimpse of a deeper order of reality, one built not on matter and energy, but on structure, rhythm, and interwoven dimensions. Despite the growing urgency around these findings, efforts remain highly compartmentalized, not from lack of cooperation, but because the implications demand a degree of caution rarely seen in astronomy. The object defies the fundamental laws we depend on: time, causality, thermodynamics, and quantum coherence. It reshapes our understanding of the universe's birth, its expansion, and perhaps even its end. The Webb telescope, once heralded for its capacity to reveal the light of first galaxies, has instead exposed something far older and darker. The horrifying object it detected is not just a new chapter in space science, it's a new genre, a mystery layered in reality-warping phenomena, whispering patterns, and ominous silence. It waits, it pulses, and with each tick of that incomprehensible rhythm, it draws us closer, not physically but intellectually and existentially, into a realm we never asked to see. And yet we look. We have to. Because in its terror lies truth. In its incomprehensibility lies possibility. In its stillness, the future of our understanding shivers like a taut string stretched between stars. The object is there, watching, waiting, changing everything. The James Webb Space Telescope's discovery has not only unsettled scientific consensus, it has fractured the landscape of cosmology itself. As researchers dig deeper, it's becoming clear that the horrifying object doesn't just defy known physics. It may operate according to an entirely different rule set, one that suggests the universe we inhabit isn't as uniform or consistent as we've believed. In recent weeks, computational astrophysicists have noticed that simulations attempting to replicate the object's behavior consistently fail unless an entirely new constant is introduced. This constant, which is being referred to as psi, does not align with any known physical quantity like gravitational force, the speed of light, or Planck's constant. Instead, psi seems to govern the probabilistic geometry of an object. How likely space is to form or collapse in a given area around a mass under unusual quantum or relativistic stress. This new variable opens the door to an unsettling concept. The geometry of space might be conditionally malleable, responding not only to mass and energy, but to specific structural alignments within objects that we haven't previously understood. This discovery has triggered a cascade of theoretical activity. Could other astronomical anomalies, the strange rotational speeds of galaxies, the unexplained structure of cosmic voids, the elusive nature of dark matter, all be symptoms of a more complex interaction between spacetime and psi? If so, the object detected by Webb might not be unique because it contains psi, but because it exhibits it in an unshielded, raw form. That would make it less an object and more a disruption, an instance of geometry unraveling into something else entirely, something outside the known topology of the universe. Efforts to model this mathematically have led to chaotic results. Attempts to map the object's influence using multidimensional tensors or compactified dimensions have resulted in simulations collapsing after only a few iterations. Computer systems begin to behave oddly. running hot, freezing, or even generating recursive outputs, as if the calculations themselves are being drawn into some kind of infinite logical regression. Programmers and mathematicians alike are beginning to wonder if our very systems of arithmetic, designed within and for this universe, are insufficient to decode what we are seeing. The implication is staggering. Mathematics, once considered the universal language, might be incomplete when faced with hyperdimensional phenomena. Meanwhile, observational astrophysics has started noticing effects not just in Webb's field of view, but in archived data from other telescopes. Retrospective analysis of deep field images from Hubble and Spitzer reveal a faint consistent shadow in the same general area of sky. At the time, it was dismissed as background noise, but now researchers believe the object, or perhaps its outer influence, has been bleeding into our observational domain for decades, if not longer. The fact that it was overlooked suggests a deeply disturbing possibility. Our universe may be riddled with phenomena we can't perceive unless specific observational conditions are met. Webb simply happened to have the right instruments, sensitivity, and orientation to reveal it. This leads to another fear, that the very act of observing this object may be changing it. Quantum mechanics has long demonstrated that observation affects outcome. At subatomic scales, particles behave differently when measured. Waves collapse into particles, probabilities become realities. The horrifying idea emerging now is that the same principle might be applicable at cosmic scales. If the object is sensitive to observation, not biologically or psychologically, but structurally, then our gaze may have activated it in some way. Its pulses could be a response to being noticed. Its gravitational lensing may have intensified after the first detailed scans. Even its apparent movement could be a kind of reaction to the increase in attention focused on it. If this is true, we may be facing a feedback loop of cosmic proportions. The more we study the object, the more it reveals, and the more it mutates. This isn't necessarily sentience, but it does suggest an object embedded with responsive protocols. Some theorists liken it to an interstellar mirror, one that reflects not light but inquiry. What it shows depends on how we look and possibly who is looking. The cultural ramifications of this idea are profound. Ancient philosophies, once dismissed as mystical, spoke of the universe being shaped by perception, of reality responding to consciousness. Modern physics is now brushing against the edges of these old beliefs, not through faith, but through observable data. The horrifying object could be the first empirical evidence that the universe is not a passive backdrop, but a reactive system. That realization is starting to blur the lines between observer and participant, scientist and subject. In more practical terms, the object has also begun affecting spacecraft communications. Deep space probes positioned in adjacent sectors of the sky have reported transient data losses, brief blackouts where instruments fail to record or transmit. In most cases, this would be attributed to solar interference or onboard malfunction, but the alignment of these disruptions with the object's pulses is uncanny. It's as though space itself is undergoing a momentary reconfiguration that erases or displaces information. Even more unsettling is the discovery that certain timestamps in affected logs are missing entirely. Not corrupted, but completely absent, as if time itself blinked out for fractions of a second. Timekeeping systems aboard satellites and Earth-based observatories have also begun reporting micro-variations, nanosecond-scale inconsistencies in otherwise hyper-precise atomic clocks. While minute, these anomalies are global and increasing in frequency. Whether this is due to a fundamental instability in space-time or a signal rippling through some deeper level of physical law remains unknown. The thought that time itself might be fluctuating even at imperceptible levels has triggered quiet concern among agencies responsible for global positioning, communications infrastructure, and power grids. Time is not just philosophical, it's infrastructural. If it begins to fragment, everything does. More research has now suggested that the object might be acting as a convergence point, a place where multiple cosmic variables intersect at once. Gravity, quantum uncertainty, entropy, space, time, even P's, all compress into a singularity-like behavior without forming an actual singularity. This convergence effect could mean the object is a boundary condition, a naturally occurring or engineered edge case where reality stretches thin, revealing what lies beneath. It's a metaphysical event horizon, visible, measurable, but conceptually unreachable. One of the strangest emergent ideas is that the object might not exist in a traditional sense at all. It may be what some theoretical physicists now refer to as a meta-object, a construct whose presence is distributed not through space, but through informational complexity. In this view, the object is less a thing and more an expression, like a paragraph in a cosmic equation. It doesn't sit in space. It unfolds through layers of cause, effect, and interpretation. Observing it is akin to reading a line of code embedded in the operating system of the universe. Under this paradigm, reality becomes modular. The object is just a node, a dense self-referencing expression in an algorithm that defines existence. Its presence suggests there may be others like it, each with different roles or parameters. Some may encode laws of motion, others might define constants, or delineate the interactions between particles. If this is the case, we're not exploring space. We're navigating an informational architecture disguised as a physical universe. The mere suggestion of this model has galvanized philosophers of science and epistemologists. How do you test an object that rewrites the conditions of testing itself? How do you measure that which alters your measurement tool the moment you apply it? Even language seems to fall apart when trying to describe it. We are, perhaps for the first time, encountering something that exists on the border of knowability, where data becomes paradox, and understanding becomes its own limitation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on this discovery? What do you think JWST found? We want to hear from you. Thank you for watching, and see you next time.